It's my great privilege to introduce our esteemed speaker of today's session one, Professor P. Naveen Kumar, Chairperson of the Board of Studies at university level and Professor of Electronics and Communication Engineering at the University College of Engineering, Osmania University. Professor Naveen Kumar is a highly accomplished academician and researcher with over 25 years of teaching, research, and administrative experience. He has been instrumental in guiding several PhD scholars, with 7 of them successfully completing their doctorate degrees under his mentorship. His remarkable contributions include publishing around 120 research papers in reputed international and national journals and conferences. Our visionary leader, Professor Naveen Kumar, has established the Advanced GNSS Research Laboratory at Osmania University in collaboration with ISRO. He has also played a key role in the creation of Osmania TV, the first university in India to launch its own satellite TV channel for educational broadcasting in association with the Department of ITE&C, Government of Telangana. In addition to his academic achievements, Professor Naveen Kumar has successfully completed several major and minor research projects funded by prestigious organizations such as ISRO, TST, and the World Bank TQuIP. His efforts have also resulted in numerous MOUs with national and international institutions, including CMET, SAC, ISRO, and OTH University, Germany, among others. Professor Naveen Kumar's contributions have been widely recognized with numerous prestigious awards, including the Professor Srinivasan IETE Memorial National Award 2024, the Dr. Vikram Sarabhai Memorial Award 2024, the Osmania University Vice Chancellor's Award 2022 for Research Excellence, and many more. He is also a fellow member of several professional societies like IET, Institute of Engineers, and an active member of numerous government committees and academic councils. Professor Naveen Kumar's global reach is evident from his academic engagements across several countries, including USA, Japan, Germany, Italy, and many other countries. It is indeed an honor to have such a distinguished scholar and innovator with us today. Now I'll hand over the session to Professor Naveen Kumar sir to share his valuable insights with us. Naveen Kumar sir. Naveen Kumar sir, are you there in the meeting?
Yes, madam. Just I'm going to just join.
You can take over the sessions.
Oh my God. Just 1 minute. Yeah, I hope you are able to hear my voice. I'll just share my screen. It's saying can't share my screen. Hello.
Sir, we're getting an echo of your voice.
Hello. Are you able to hear my voice?
Yes, sir. Now it is very clear.
Yeah. Thank you so much. There's a lot of issues were there, but thank you, Professor Ajira Pathur, for introducing me, and a very good evening to all the participants across the country. And I'm very happy to be associated with this particular program, and also to deliver the talk on smart grid and decentralized energy systems. So this is a very new upcoming topic, and a lot of things are there where every discipline will be able to contribute to a lot of work in this particular area. So the outline of the presentation goes that I'll be talking about the introduction, the smart grid, and the electrical grid versus smart grid, and I'll also be talking about the smart grid activities in India, and also some of the government of India who has started this NSGM scheme. So that also I'll be talking about. Hello. And there's a DES. Then we'll be talking about smart grids versus DES. What is the difference among these two? And the issues, the energy storage, the challenges and the future aspects of DES, and also the smart grid and IoT, where a lot of IoT applications are there in the smart grid. IoT smart grid and the smart metering solutions, which is the one of the challenging tasks to be implemented, especially in India, and IoT-based smart energy grid systems for the sustainable cities, and electrical load management and maximum demand control. And also we'll be talking about some of the challenges in implementing the complete set. So if you look at here, we have the complete electrical grid. So we all know that we are talking about this since long time, and there's a lot of electricity related aspects which is there. And this electric grid, it is network that would be able to deliver electricity from generation sources to the consumers across the world and wherever it is there. And it's a very complex system that's considered one of the most impressive engineering feats of modern era. And when we talk about electric grid, I want to throw one important point that all the electrical grids, these are all synchronized with respect to the time. That is the accurate time, GPS time, the satellite time. So all the grids should be synchronized. That is very, very important. So synchronization is very important, and the grids can vary in different sizes and also the kind of complexity, including at the national level, regional level, all micro and smart grids and many other applications. So, and we'll also see more about the smart grid, and they can function autonomously or with less human control to produce the electricity. And when we see the main components of the electric grid, basically the complete network, it would consist of the power to be generated. So where the power plants will be able to generate the electricity, either it could be a nuclear power plant or any other power plant, and from there the huge transmission lines are there, high voltage power lines where they carry the electricity over long distances. Then substations are there where they need to be step down voltage so that it can be distributed to the consumers or the industrial area, etc. Then we also need to have the distribution networks which would deliver the electricity to the end users. So these are the major components of an electric grid, the four basic components. And apart from that, there are many other components of the electric grid which are there. So they include about the advanced metering infrastructure, where you need to have different kinds of meters with two-way communication. And we will be also talking about the distributed energy resources and the reactive powers. So if you look at the figure also, we have the complete electrical power distribution, which is there either from coal plant or nuclear power plant or hydroelectric plant, or even some industrial power plant, medium-sized power plant, at different locations. The major, the electricity has been generated from different sources, and from there it goes to the transmission grid, and then from there it goes to the step-down voltage. Need to be stepped down to here, and then it has to be distributed to different service locations. So thing was going on good. But as the number of houses and usage is increased, the electrical power grid has got a lot of changes are there. So that need to be tackled. And we have the smart grids here. That is the which we say it's an electrical network which would use digital technologies, sensors, and software to better match the supply and demand of the electricity in the real time, while reducing the cost and also maintaining the reliability and stability of the complete grid. So electrical grid would not be able to use the digital technologies, whereas smart grid will be able to use the digital technologies and different kinds of sensors, so that we can have optimum utilization of the complete power at all locations and improve the efficiency and adaptability of the system. We'll see about the DES and the latest. So here we have the grid management system, which will be connected to the hydroelectric power generation, wind power plant, solar power plant, then smart home, electric vehicles, different kinds of cities, factories, and so many different places are there. So from this, we do all this through the use of the digital technology networks. So smart grid, we can say it is a very modern electrical system or electrical grid, which uses the ICT communication networks, and it is able to collect information from the behavior of its who are maybe the customers. So in case of smart grids, it will automatically work itself to be more efficient and reliable in distributing electricity. And these smart grids will be able to use automation, sensors, and real-time data analytics to monitor and manage energy flow and all that. Then it will be able to interact with the main grid, and this grid consists of consists of different power stations, then electrical substation, step-up voltage. Everything will be taken up into this particular consideration. I will also see what is the difference between the smart grid and the electricity grid. So the smart grid will be able to use the modern technology to enable two-way communication and power flow, whereas conventional grid would be able to use only one-way model. And there are different parameters where we can differentiate between these two in terms of power flow, communication, efficiency, and other things. So when we say power flow, anyway, conventional grid has got only one way of power from the producer to the consumer, whereas the smart grid has a two-way power flow. And when we talk about the conventional grid, it has got limited or very less communication capabilities, while a smart grid uses smart meters, sensors, different types of control systems to gather real-time data. And when we talk about efficiency, smart grid can be more efficient than a conventional grid because it could be able to balance the supply and demand in the definitely in the real time. And when we talk about the reliability, so definitely smart grid will be more reliable because it would be able to identify the issues in the network, and it can be resolved without any kind of intervention. And power losses, optimal uses of the power will be there. So there will be very, very minimal power losses when compared to the conventional grid, which will be looking into that. Scalability also, smart grid can be more scalable than that of the the other conventional grid, which can integrate renewable energy. So existing, if you look at here, the existing grid and the the kind of the smart grids. So we can clearly see existing grids will have most electromechanical devices. And as I said, it's a one-way communication. It is most centralized generation. You generate the power at one centralized and distribute to different places. And you got sensors are also not widely optimally used there. And also there is not much of lack of monitoring. Only manual monitoring is available. A lot of failures and blackouts are there, which will be able to tackle. And when compared to smart grid, it's less energy efficient and all that. But when we look at the smart grid, it is digital in nature, two-way communication, distributed generation, and then sensors have been highly deployed there for different kinds of applications. And the smart grid is made in such a way it is digital self-monitoring system. And because of the other AI technologies, etc., it is more IoT is also being used in the smart grids, and it is more digital self-monitoring, and it is adaptive and intelligent, where we'll be talking about the smart meters also. So more of this IoT AI technologies are being used in this smart grid, but existing the conventional grid, we are not able to incorporate them. And also, since we are using this new technologies, it is more energy efficient. And customers also, will get an alerts on their usage, and they'll be able to work it out. And when people talk about electric energy grid or power grid, in fact, all these terms are referring to the transmission system for the electricity. And they're talking about the synchronized power providers and consumers that are being connected by transmission and distribution lines and operated by one or more control centers. And we have one that is a mission, that is National Smart Grid Mission. So that is a NSGM. It's a it's been initiated by Ministry of Power, Government of India, And this was established in the Indian power sector to basically to plan and monitor the implementation of the policies and the programs related to the smart grid activities in India. The government of India, they have started this particular program, and several objectives were there, and they have made some of the deadlines which need to be monitored. So this national smart grid mission is able to, use different policies and do that one. And it is an institutional mechanism for planning, monitoring, and implementation of policies and programs related to the smart grid. And since it's housed in the Ministry of Power, considering the fact that most of the people are the stakeholders of different electricity power networks, and the regulators, electrical power manufacturers, central electricity authorities, they all are associated with this Ministry of Power. And they're all been considered in drafting the guidelines for this national smart grid mission. And apart from that, there are many other what you call ministries who have been involved in this Ministry of New and Renewable Energy, Urban Development, and Heavy Industries are also been associated with this mission, because it is a complete development in all particular aspects. The main objectives of this particular NSGM, National Smart Grid Mission. So they need to address the key issues of the smart grid initiatives on large scale across the country, and also make the Indian power infrastructure cost effective, and it should be more responsive, and it should be reliable. So a 20-year perspective plan for integrated inter-regional and interstate and intrastate transmission network for the country as a whole has been formulated, and that would be the main crucial backbone for the vision of 24/7 power for all the homes in India. In fact, the main aim is to provide power, and apart from that, the consumer also should be able to understand how much he'll be able to use, what is the kind of cost it is involved. And then next one is the whatever power is being generated, that need to be optimized use and have less of the distribution cost and other things. So the NSGM, actually, it has got they conducted many different international national workshops. They developed many courses for their, the people who are involved, and many training programs were there. Brainstorming sessions were taken up, and they also rolled out the smart meter rollout plan, which they submitted, and they want to implement across the country, that everywhere the conventional meters should be replaced, and they have to go for a smart meter and have a better efficiency. And different projects were being rolled out, and model regulations are also been different adopted by different states, and but not completely taken up across the country. So the governing, if you look at the objectives, it need to frame the policies, it need to frame the targets and programs, it need to have proper funding from different organizations, and also should have frequently meeting for about half-yearly meetings, and also program review. So members involved in the complete design and development of this program is from different sectors who are there, including DOT, DOIT, power, and different kinds of states who are also involved in development of this particular program. And it has been completely monitored to see that the complete power sector has been properly utilized, and reduce the the generation part and other things. So we'll see quickly one small video which is there. I'll be able to share that. It is based on the smart grid, the animation part. I'll just present that particular one. I think audio. Just Okay. So smart meter will have a things information to record and send data, and also they were using the latest technologies, and also they will be able to record the different kinds of anomalies, disruption, and send the information to the supply from where it is coming and all that. That is the, and you can also see what are the benefits of different equipment which are involved in this particular system. People, it is like a dashboard where you get all the complete information. You'll be able to get that. So these are some of the important aspects which have been involved in this smart grid, electric grid, and the other things. Then we'll see about DES, decentralized energy system. And that is a system that would be able to generate energy closer to where it is used instead of a centralized power plant, and it is then sent through the grid. So in fact, in the earlier system, we had only one particular generation point, and from there it has been sent to the other consumers. But here we will have the energy generation at different locations and wherever it is needed, and that can be used. So decentralized system can be used to the power a particular locality, a particular community, or a particular very small region. There itself you can generate the power, and again that itself can be utilized in that particular region itself. That is the point of contact even the villages, instead of getting the power from the centralized locations. So DES systems can have a lot of things. You can have the reduce the carbon emissions. Decentralized energy system can help reduce emissions, and they'll be able to use more of the renewable energy sources, increase the security of supply, and also by reducing the transmission losses, and be more cost effective and more flexible systems than compared to the centralized systems, and increase the community income, and also because they are able to generate there itself, and they can also increase the more of the market transparency. So decentralized smart energy systems are characterized by locating the energy production facilities closer to the site of the energy consumption. So if you like a small locality where there are around 50 houses are there, then for that 50 houses itself, you will be having one point where the energy will be produced, and it will be distributed only to that particular area. And in case excess it has been there, that can be sent to the other location. So this way, what will happen is more optimal use of renewable energy as well as combined heat, power, and also reduce fossil fuel use and increase eco efficiency. Everything will be able to take it up. So if you look at here in this one, you have the centralized power which is generated, and finally it is going to the distribution network. But if you look at the other locality at a different location, solar plant or even the local CHP plant, or wind power, wherever it is feasibility is there, they'll be able to generate and distribute to that particular location, and they'll be used for this. So this is what if it is adopted, and we'll have lot of less of the transmission will be there. The same place you are going to generate and same place you are going to utilize them. So in a DES, energy is produced from various small scale or renewable energy sources. That could be a solar cells or wind turbines or even micro hydro systems or biomass generators. Wherever it is feasibility is there to that particular locality, they'll be able to use them, and they can be able to work out. For example, if you take the wind turbines, small scale wind turbines would be able to harness the energy, and they'll be able to produce the electricity. And then batteries are there which will be able to store the excess energy for later use, including those in electric vehicles or even solar panels. If we are talking about 50 houses, and on every house you can put the solar panels, and that itself will be able to generate electricity from the sunlight and can be used within that small locality. So there is no need to depend upon the centralized power systems. And apart from that, in the DES system, we'll also be using the smart meters. Just now we have seen a video where the smart meters are being put up at particular location. They'll be able to provide the real-time data on the energy generation and energy consumption in that particular location. And apart from that, AI optimization. In this one, the customer will be, or the consumer will be able to tell them if you are going to use on this particular day. Suppose you are using around 10 units on particular day, and then if you are using consistently the same level on this particular month, then you are going to get approximately this kind of bill, and it will all be there. So it will be able to also balance the power grids, and also will be able to help the optimize energy use. Then community systems are there where they'll be able to store excess renewable energy that will be there. And this will be able to, DR system will be able to provide more flexibility and scalability when compared to the, coal-fired or nuclear power plants, where they require longer distance for its transmission. And when we talk about this DS system, they can be easily added, removed, and based on the demand, you can make a lot of adaptable changes. Evolving energy landscape. So many flexibilities are available in this particular distributed energy systems. And definitely either zero or no transmission losses will be there, because same location you are producing it and same location you are able to use them. And you have enhanced grid resilience. You can provide power backups during the outages, which will be there because you're generating and storing in your own location. And whenever there are outages, we can use the same power backup instead of waiting for that one, and enhancing the grid resilience, ensuring the continuous energy power supplies, and you'd be able to generate your own energy and all that. So instead of depending on the centralized power systems. But there are also some of the challenges in integrating these DERs, and renewable energy sources like solar and wind are intermittent, meaning their output fluctuates depending on the weather conditions. So this is very, very important. Though we say the DE systems are the best, but still based on the weather conditions, we'll be able to have an issue. So for this one, actually, as long as the proper weather conditions are there, need to store the information, store the power, and that need to be kept right, and this should be tackled. And the grid stability, integrating DR into grid can pose some challenges about the stability because of the very sophisticated control systems which are used in the distributed energy systems. And apart from that, DR system can sometimes generate more power than they consume. So there is a possibility of the reverse flow of the power, and it may also give some issues. So these are some of the challenges, even though we say DS is a better system, but need to be challenges need to be tackled. And when we look at these two, smart grids and DES, when we look at these two things, in decentralized grid, energy is produced from various small scale distributors, where we have already talked about that. But we need to take care of these particular challenges and need to be maintained at the location wherever it is been generated. A lot of care is to be taken care. So that is of the very, very important concern, and those challenges to be done in the real time. And when we talk about this, the system, they'll be able to use the small scale power generation technologies located near the points of use. And DS definitely reduce the fossil fuel use, increase eco efficiency, and make better use of renewable energy. And as I said, the Ministry of Power mission definitely slowly they will maybe introducing some of the benefits if they use the solar power plant, which is giving subsidies and same place generation and utilizing at the same location instead of depending on the centralized part. And variety of energy sources can be used for different locations, and they based on the large geographic areas. So people start generating and sharing energy locally is not only a necessity to make the energy supply more sustainability, but it also has the positive side effect of strengthening the cohesion in the local communities. So that is also very, very important aspects in this particular, and will be able to use the resources in the optimal level. Otherwise, only depending on the centralized one is not the particular one. And DES is characterized by location of the energy production facilities closer to the site of energy consumption. And it is a very relatively new approach in the power industry in most countries, where as of now it is not completely been taken up because of the various kinds of issues and the initial cost and the maintenance of it also. And the power industry has focused on developing large and centralized power stations and distribution lines to the consumers in the region. And DS should put power sources closer to the end users, and thereby reducing the transmission and distribution inefficiencies, and also keeping in the economic and environmental cost. That is also very important. And apart from that, this DS infrastructure components, we have core components are there: distributed generation, embedded generation, on-site generation, dispersed generation, and decentralized generation. These are all very, very important aspects which need to be taken care. So both heat and electricity can be generated in a decentralized manner, and they can be distributed and or they can be used at a proper location. Shifting to decentralized power allows for coordination between heat and power generation in the combined heat and power plants, and doing that the system efficiency with electricity and heat production, which is a byproduct of this particular system. Apart from that, we have a lot of issues are there in the storage. You completely generate and use it, but what about the storage part? So the most important aspect of this is also one of the important aspects is electrical energy cannot be stored and must be generated as needed. So you cannot use it continuously. Apart from that, we also discussed that power, the weather also is going to have this particular one. So a lot of challenging aspects are there. How much energy which is generated can be stored, and it need to be stored safely and can be distributed in the localized one, or whether it can be passed on to the centralized location. So these will be lead to new difficulties in controlling the supply to the best match demand. And such storage state-of-art batteries need to be developed. Compressed air and pumped hydro storage can keep the grid stable by storing energy when supply exceeds the demand and feeding it back to the grid during the peak hours. So that all communication has to be taken care, involving a lot of new digital and AI technology should be there. And storage can and should also be decentralized to maximize its efficiency, and it can go off-grid or on-grid connected. That is also which can help during the off, when weather conditions are not proper. And apart from the demand response technologies, they'll be able to provide another tool to manage grid stability when decentralized generation is grid connected. And grid management, it has focused on supply management, and the new technologies like smart metering or allow real-time monitoring and communication between producers and consumers of electricity to optimize grid usage. All these are very, very important aspects which need to be taken care. With distributed generation and storage, many consumers of electricity will also at times be the producers of energy. So that is another one. So consumer itself will be able to possible to become the producer of the energy, because there will be the need of the point, and also they'll be able to generate revenue if they're able to show the generated power to the centralized power distribution system. So infrastructure design is very important for feeding the potential access generation in the grid. And apart from that, they can also sell the power to the lower microgrid or mini grid to the several regions. And linking distributed generation resource through a grid system will increase the reliability, particularly when intermittent renewable sources there. And they're also very important components of off-grid decentralized energy systems. So even a small solar home system for a single housing unit would be able to operate more efficiently with battery storage, and the users will be able to manage their own loads to best match supply the fluctuations. We've also seen the limitations when we talk about this digitalization. There's a lot of cyber security risk will be there, and they're also vulnerable to the hacking and cyber attacks. So proper anti cyber security, proper security should be provided in these smart grids where hackings and other issues will not be able to happen. And grid compatibility is another important thing. Not all the power grids are equipped for these distributed energy systems, and that's another particular one. Then we have intermittency of the renewables. Renewable energy sources like solar and wind are always not consistent. So though we say it is very good and all that, but these are all these some issues which is there. So there is a need for development of better cyber security to tackle those issues, and also to better development of power storage technologies. And apart from that, renewable energy sources are also they were not able to consistently which are available. So in future we may have increased adoption because the advantages are more, and with the improved the technological advancements, we can continue innovation in the battery storage, energy management systems, and renewable energy technologies will drive further adoption of DES. And apart from that, we have seen the policies that a national mission on this particular government policies and incentives will definitely play a crucial role in promoting this widespread adoption of DERs. And decentralized energy future is a decentralized, and it will empower the individuals and communities to take care control of their own energy needs. We will also see some of the very good examples which are there in this one. We have the another video which is about the decentralized energy systems, which are the need of the hour. We will just look at this. I'll just explain you. So since long time we were depending on this particular centralized energy systems, and we were using them. Now when we talk about DES, we'll have a lot of things, biogas technologies which are there, solar panels, wind power, all can be decentralized. So we could say DES systems are a game changer to the power sector. And you could see a lot of communities can be powered here. So wherever we are going to work, there itself it will become a power generation and commission. And you can really imagine the kind of transmission lines can be completely eliminated. So we have a microgrid which will be connected to the main grid, and it will be very flexible, and it will be able to power to small localities. So, for example, one particular home can be completely converted into a mini power plant itself. Electric vehicle charge, your own power can be charged there itself. And this is the whole community which has been, powered by a biogas plant at that particular location. And whatever the heat which has been generated, that can be used for the heating water, and other systems can be developed for that one. So because you're generating it at local level, there is no transmission losses which we can see. And all the solar panels across all the homes can be integrated, and we can create a bigger one utilization of that. And apart from that, this would be really a source of income for the homes when they utilize this DAs, and extra power generation can be shared to other locations. Now, what are the challenges which is there? Clouds, when they come, sun is not available, so you'll have this issue. So a lot of power regulations need to be implemented in integrating these DA systems to the main grid system for saving the power and all the things. Recently, we must have seen the China also on the mountains itself. They have spread a lot of solar panels, and that energy has been generated, and that has been distributed to other locations. That is there. So that's of the very, very important aspect which this can play a major role in this one. And in this, when we talk about the smart grids, in fact, the IoT is one of the very important aspect which has been integrated. And definitely smart grid in IoT would be able to benefit the environment by optimizing energy distribution, reducing the energy waste, integrating renewable energy resources efficiently, and enabling real-time monitoring. And more sustainability and all that is there, and it is digitally enhanced system. And IoT would play a major role. So you connect through internet to all these particular locations. You can connect your homes, factories, unclear power plants, thermal power plants, so many things which are there, all can be connected, and it can be monitored. So IoT would be able to enable machines to complete the tedious tasks without any kind of human intervention, and you can automate the processes, reduce the labor cost, cut down on the waste, and improve the service delivery. And also, it is very less expensive to manufacture and deliver the goods, and they offer the better transparency to the customer transactions. So when we talk about smart homes or smart city, self-driven cars, IoT retail shops, farming, wearable smart grids, industrial internet, everywhere the IoT would be able to play a major role in this particular smart grid technology. So, when we talk about the DES, again, in that we also going to use the, this IoT centralized system where without much of the human intervention, all this can be taken up, whether it is energy storage or energy saving, or, the electric vehicle charging, smart house, smart city, etc. All these things can be taken up by using this particular technology. And really, when we have this IoT in smart buildings, we can have the energy consumption reduction, definitely, because you are going to get everything on a graphical user interface, and proper management of the smart grids would be there. Better energy storage systems would be there. Electric mobility is also another important thing, and you would be able to monitor and control of the both indoor and other systems, which is the one of the most important thing. And using this technology, the new smart meters were been introduced. So across our Indian country, actually, there are two challenging tasks: whether to replace all the existing conventional meter with the smart meters, or is there any technology which, with minimal kind of changes in infrastructure, whether we can integrate the smart meters or convert the existing conventional meters to smart meters. It's very, very important aspect. So because they are able to give you the collection and storage of the data, device management, etc., and also creation of rule-based alerts will be there. If you're using excess of the power, then you get a really alert, and they'll alert you, and the generation of comparative reports also will be given to us. So many things will be able to do that one. So the consumer will be able to inform through this smart metering about the resource consumption, such as energy, water, gas, etc., through modern metering devices connected to the internet via IoT. And biggest challenge is integrating all the devices into meaningful smart metering solution is another important thing. And also we can use this smart metering for accurate energy accounting and billing. If you look at it a larger scale, or even at a particular small locality, where you'll be able to eliminate the wasteful practices on the factory floors, or when we talk about spot water leakages, or reduce gas pressures, or encourage efficient fuel consumption, or even sometimes to prevent theft and all that. That is all is possible using that one. And we have seen about the smart meter also. So this is one of the GUI of the graphical interface of the IoT dashboard, where you will find the the kind of the amperes, voltage, and the kilowatts which is there, and what is the overload threshold. You can also keep it there. Your usage bar graph will also be shown on which day, which time you use it, and will also be shown about the voltage fluctuations. So many things will be shown you on the screen, and you'll be able to monitor usage and understand these kinds of trends, and proper optimization can be done. So a lot of research work is also been going on, and a lot of papers are also been published on this IoT smart metering solutions. In fact, it is very important for security, and data protection is very essential in the smart cities using this one. When we talk about the digitization, again, therefore the security will be very, very important, because you're connected to the internet. Sitting at one place and across the world, you can completely disturb the other smart grid location. You'll be able to manipulate the smart grid, and all that is coming up. So again, new technologies are involved in this particular one. So IoT powered solutions will be able to use the sensor-based approach for establishing automation. It would be able to help handle real-time data and storage. It's safely on the cloud platform, and it would be effective data management systems. And you'll be able to verify and measure the energy consumption, define energy goals, set the energy KPIs, create detailed reports automatically, and you'll be able to set the deadlines and all these things. So using this technology, you'll also be able to do the proper energy management can be done. You'll be able to check the proper management of the energy, and you could also be able to check the power outages, system distribution disturbances, reducing the downtime, and you'll be able to in industrial sector, it will be able to stimulate the innovation in energy management, and you'll also be able to predict what would be the future energy consumption. So these are all very, very important, and therefore you can even plan for a higher big business levels for planning your cost, and pricing models can be done. And smart grid actually apply the principles of Industry 4.0 to achieve power system with better system operation, higher energy efficiency, reduce generation operation cost, lower greenhouse emissions, reduce downtimes, and all the other issues which are there. So smart energy meters, we can say they are web-based head-end system application software. They'll be able to measure whatever the electrical parameters which are there. And apart from that, the theft and tamper detection also, you'll get an alert to the user, or even tampering to the software also, the an additional feature which is there, people will be able to get the alerts. So it is completely foolproof, and sitting at one place, the power sector can be completely controlling the whole things. So IoT based model, which will be connected from the source to the load, and it would be communicating with the nearby microgrid for exchange of power during low demand and high demand. So during low demand and high demand also, that also can be managed using this particular technology, and you'll be able to use the proper optimization. So adopting this, actually, we could say we will be able to, cut electricity consumption by over 1.6 petawatt hour by the year 2030. If if you are able to implement this particular smart meters, and that would be enough to power more than 150 million homes for a whole year. So that kind of things which is available with this particular system. And solar powers and thermoelectric effect power can power IoT devices. And whenever we are saving and proper utilization is there, it's nothing but the generation of the power. And for that, we also require some of the IoT setup requirements, backup needs, need of the power, etc. So when we took up the example of a local solar farm, which would generate more energy than what it is consumed, so that can be distributed to the smart grid and help the reduce of the demand of the distance power plant. That's another important aspects. So future applications, they all depend on the real-time market, the kind of load forecasting, the kind of maintenance and etc. And advanced metering infrastructure will also be there. Provides a remote meter reading, theft detection, customer prepay. Prepay is also another thing like that of mobile, which are prepaid cards will be there. Mobile workforce management, etc. will be there. And the components, all this need to be required in complete implementation of smart grid and the electrical power grid. You require controllers, power generators, etc. So it's a very big project which need to be taken up, and will be able to detect and manage the network failures. Intermittent energy source such as wind and solar can increase the strain on the traditional grids. That's another important aspects which are already available. But proper billing will be there when implementation of this grid technology, which will there, and it will be able to deliver outstanding results, and will be able to minimize the completely the what you call the issues with whatever we are facing. So load management will also be able to allow the utilities to reduce the demand for electricity during peak usage times. That is known as peak shaving, where it will be able to reduce cost. And robust control and communication technologies have been employed in the implementation of this particular technology, and will be able to take care of the maximum demand control, and peak times will be able to take care of the issues. And it will be able to automatically switch on and off of various consumer loads at different specific intervals, eliminates the need for manual load switching based on time, while providing the control and monitoring capabilities for all the electrical devices using this particular IoT technology. Challenges are many are there. IoT energy management, we need to take care of the monitor and optimize the energy compliance. And also we need to take care of the IoT backed sensors to keep an eye on consumption patterns, and those solutions will be utilized to manage and optimize energy consumption patterns by taking complete control of energy data. That is very, very important. So when we talk about implementation of smart or DS systems, connectivity is very important, because if there is no connectivity, there's nothing that we could talk about the smart grid or DS systems. So integration of your new IoT connection to the existing legacy system is a huge challenge because of the large technological generation gap, and also modernization of the existing infrastructure. It is there. And privacy, a lot of privacy data security issues will be there. High number of important consumer data will be involved, and data can be manipulated, or data can be stored, etc. Integration is another important thing. Integration with existing platforms is a very big challenge for any of the company, and the whole situation becomes even more difficult in the energy sector due to the big complexity of the network infrastructure. So intelligent energy management solutions, which are more required to identify the improved areas, keep track of effects of the digital energy consumption. Advanced analytics are required, and IoT solution based on the AI and ML techniques will be able to provide proper insights into the business, and it will be able to provide the critical energy parameters such as power interruption patterns, voltage, frequency trends, and also it will be able to help in enabling real-time alerts, etc. And real-time energy monitoring can be done. Predictive analysis can be done. Centralized dashboard will be there. and also localized dashboard will be there to monitor the multiple sites, respond to various alerts, analyze the metrics, and then you can come out with a product proper predictive analysis, and a lot of analysis can be done, reports can be generated, and preventive measures can be taken care of. With this, you can have lower costs, boost efficiencies, and reduce environmental impact. And we'll also be able to have the smart and or even a customized reports at a particular location can be done. So these are all about the IoT-enabled building energy management systems, which are power trading broker, virtual power banks, distributed energy IoTs, and renewable energy IoTs. And apart from that, the other side, we have the building and household information will be there, building energy demands, real-time generation, renewable energy supplies, etc. So many will be there in this particular technology. So a lot of benefits will be there in implementation of the smart grids and DAs, but these particular things should be taken care and very soon. But even though we have the challenges, that all should be implemented, and so that we can get we can transform into that, save them. Once you save them, then we can less depend on the power generation, and it will be able to use for smart and more efficient way with the technologies which are there. So thank you very much for giving the opportunity on this, sharing my views on this technology and the challenges and the advantages and the limitations of that. Over to Hazira.
Thank you, sir.
Yeah, thank you so much.
Once again, good evening to all participants. On behalf of the organizing committee and all participants of this faculty development program, I extend my heartfelt gratitude to Professor Naveen Kumar sir for delivering an insightful and thought-provoking session on smart grids and decentralized energy systems. So your session has provided us with a deep understanding of how smart grids and decentralized energy systems are shaping the future of energy management and sustainability. We are sincerely grateful for the time and effort you have invested in sharing your knowledge with us. Your valuable insights will undoubtedly help us in our journey to contribute towards sustainable energy practices and smart technology adaptation. Thank you, sir, once again for your valuable contribution to this FDP. Thank you so much.
Thank you so much. Thank you very much. Yeah.